with you, Marley, our trusted astronomer, just a few doors down here in the unceded territory of the Musqueam, Squamish, and Tsleil-Waututh. How's it going, Marley?
It's good. Big day for people like me. Are really into Star Wars. Big day.
Well, a big day for both of us. We've got a big event tonight. We have Industrial Light and Magic. We've got three of the directors of the animation, the background special effects on the show Andor that are going to be in our auditorium tonight, as well as the 501 Legion are going to be on site. There's about 20 different characters from the Star Wars universe that are going to be here in the building. So great energy. Love this for us. Because this is the universe that we love. And of course, here at the Space Center, we like to take one of the themes, and it just so happens that we've got some big news that has happened recently with a certain telescope that helps us understand the concept that Star Wars gave to us a long time ago in a galaxy far, far away. And so talking specifically about galaxies that are very, very far away, JWST gives us some new light and pictures, and you've got some interesting stuff to share with us on this. So that is going to be our topic today for this Ask an Astronomer. If you were out there on YouTube land, welcome back. We took last couple of weeks off. We had some technical difficulties, but we're back.
Technical difficulties. We were very busy. We're very busy.
Yeah. Yeah, that's technical difficulties, right?
I guess so. Yeah. I do want to note that Michael put on a blazer for this. He was not wearing the blazer before, and I just noticed, and it did make me laugh a lot in the minute. But yeah.
Well, yeah, like you have to class it up a little bit, right? Like normally here we have business casual, so we're not allowed to wear print t-shirts, but today is kind of like an exception. So put a blazer over top, but it's kind of business casual like, right?
I think so. I just think it's funny you put on a blazer on for this show in particular. But yes, glad to be back. Glad to have Michael back. It's very stressful to do it on my own or without him. So welcome back. My grandmother's thrilled. And today, I wanted to talk about JWST and galaxies. So right away off the top, I wanted to show a bunch of different kinds of galaxies. And these are the galaxies we're most familiar with when we think about them. So we think about the grand spirals, maybe the irregularly shaped galaxies that have kind of maybe an interaction going on between two, like this one in the center here. But these are what we think of when we think of a galaxy usually, right? This big grand spiral. And that type of galaxy structure is actually what our own galaxy is. So our galaxy, the Milky Way galaxy, is what we call a barred spiral galaxy. It has to do with the fact that it has a bar through the center of it. Astronomers, not super creative with names, call it as we see it, has a bar. And two major arms coming off of the bar. You can see one's the Perseus arm, and one is this something Centaurus arm. I can never pronounce the first word right. We used to think it had four arms, which is really fun. We used to think it had four major arms, and that was part of like this normal arm and the outer arm we thought perhaps were their own types of arms. But we found out, thanks to infrared data from the Spitzer Space Telescope, that it is actually just two major arms coming off of the ends of that bar. And with these grand spirals, we typically get two types. There are the barred spiral galaxies. And then in the case of the Star Wars universe, there are the just regular spiral galaxies. So I know diehard fans will recognize this as being from Legends. Copyright prevents me from using the actual one, so just bear with me. We're looking at the structure more than anything. So the structure of the Star Wars galaxy is very similar to our own, but it doesn't have that bar. It just has the giant galactic bulge is what that central part is called, and then it has the multiple arms coming off of it. How many arms they decide their galaxy has is unknown to me. But there is some information that I was able to find about the Star Wars galaxy and kind of compare it to our own, because I try to bring things back to like the compare and contrast between the two. So our galaxy, we estimate, has about 100 to 400 billion stars on the upper and lower ends of the estimate, and it's about 100,000 light years across. So it would take light 100,000 years to get across the diameter if we were to approximate it as like a circle. It's also about 13.6 billion years old based on current data and modeling that we have. and we compare it to the Star Wars galaxy, it's over 400 billion stars, so a lot more packed in, to something a little bit bigger, 120,000 light years across, but something about the same age, about 13 billion years old. So really, we've got these two grand spirals happening, these two large dynamics of galaxies happening between, our universe and the Star Wars universe. And one thing I noticed just before I made the presentation is that the structure is very funny of the Star Wars galaxy, but it reminded me of how we structure our own galaxies, how we label things on them. So of course we're familiar with like the core, inner rim, mid rim, outer rim. We're familiar. I assume you know what I'm talking about when it's on Star Wars Day. I know you know, but for the general audience, that really tells us like where the planets are, right? So Luke lives on a Tatooine, an outer rim planet, or Coruscant is in the core of the galaxy, right? So that helps describe where regions are. How astronomers look at galaxies and how we define their bits and pieces is less like on a civilization scale and much more on a what we're physically looking at. So we have the whole spiral galaxy, and then we have the galactic bulge, which is that central tightly packed region. That would be kind of like the core and probably a bit of the inner rim in the Star Wars galaxy. And then we just have the disk, and that's kind of like the rest of the stuff. And then something called the stellar halo, which is like where all these stars kind of on their own all float around and hang out. And that's kind of it. There's also like the dark matter halo also exists a bit further out, but it's like on a much larger scale than how the Star Wars galaxy organizes itself. But the Star Wars galaxy, if it works much like our own, which I would assume it does, given it's got a lot of the same parameters, would also have a very similar structure happening to it as well. A galactic bulge with globular clusters, a disk, and some sort of stellar and dark matter halo afterwards as well.
So there's a couple of things that I always fascinated by when we're talking about galaxies, and of course we end up talking about the Milky Way because we're inside of that galaxy. But that image that you're showing us, we can never see that, right? Like in essence, that's just a model of what we think the Milky Way looks like. And even the one on the right before, that's also kind of, is that an actual telescopic image, or is that also like a rendering of
This one?
Milky Way, the one that had more on the edge?
Oh, yes. So this one is just the geese. This one is just what we based on modeling what we think the galaxy looks like. You're right, we can't leave it. Our sun, our solar system is really packed into this Orion spur right about here where the laser pointer is, and we can't get out of the galaxy. It's not something we can do. And so what they actually do is they look at the sky, and if you were looking into the center or like out, I think it is what they did, they looked out and you can see like the stars kind of make a path looking out that direction. And so one comes up, like the stars arc up, and then the stars arc down. And that's kind of what they led them to be like, oh, there's two arms, right? That's how we know it's a spiral shape, because it has these arms. And by following the motions of the stars and comparing them to motions of stars we see elsewhere, running the numbers tells us it has to have this type of motion, which would make this type of galaxy. Is a really like simplistic way of explaining how they do that. This other image, which I think you're talking about, this one, is also like a model, right? So we do see other galaxies edge on, is what that view is called. So this, like the one where we're looking down at it, is like face on. The one where it's just like in the plane would be edge on. And we do see galaxies edge on a lot. Like the Sombrero galaxy, I think is like the nickname of that one. We see edge on. There's a few here that are slightly tilted at different inclinations from us, but we do sometimes see them directly on that edge. And that's how we're able to see like, oh, there's some matter up here. There's globular clusters out this way, right? Is by looking at other galaxies outside of our own and taking that information and using it to inform us as to how our own galaxy must be structured in that way.
Right. So just before we move on, I want to clarify, if our galaxy was as part of the Star Wars galaxy, Earth would be in the outer rim?
Let's look at the map. I think it'd be mid-rim. I don't think it'd be that far out. Yeah, mid-rim.
Okay.
Let's say mid-rim, based on the one picture I did here. Oh my gosh, so many slides. Oh no, outer. I guess outer rim. Yeah, it'd be an outer rim world. We're pretty far. If we were to, it's slightly bigger. I would put Earth around here.
Yeah, it is kind of interesting in the Star Wars universe. What they do is that they put all of like the more populated worlds kind of like more to the globular cloud, sorry, the inner core of the galaxy. But we have no idea, of course, like we're still looking for potential worlds that could have life on them. We don't have any idea if it's more likely to be in the center. Like at this point, it seems like life is only able to be in the outer rim because that's the only planet that we know of.
The only planet we know of. Yeah. It's also like I don't know exactly what's going on at the center of the galaxy in the Star Wars pardon me universe, but like ours is not the place to be. Like like the closer you get, the more energetic and kind of dynamic and bad for life things end up being. Just radiation from the supermassive black hole that lives in the center. I don't know if there's one. There would have to be. Based on how we understand galaxies to work, there would have to be a supermassive black hole in that one as well.
Well, then, of course, if we want to transfer over to the Star Trek universe, you know what happens in Star Trek 5 in the middle of the galaxy.
I know now. Didn't know before.
You can go look it up. Star Trek 5, one of the best worst of the Star Trek franchise. Let's move on.
It's not Star Trek Day. Anyway, so how so the reason I'm showing you all these really pretty pictures of galaxies is because these are what we're familiar with, number one. And number two, the galaxies Webb don't look like this. So I wanted to make sure we had something nice to look at before we start looking at how Webb sees things, because it's not this dramatic. So these are all different types of galaxies. We have spirals, we have an interaction going on, an elliptical, and an irregular galaxy, right? These are like the three main types that we categorize them as. And what happens with galaxies, and our main question of galaxies, especially when it comes to these grand spirals, is how do they get their shape? Like what happens from when a galaxy starts to where we see them today? And why does it end up organizing itself as an elliptical galaxy or as a spiral galaxy, for example? What does actually the lifetime of a galaxy look like? And Edwin Hubble thought he had this figured out. He's wrong. He was wrong, but he thought he had it figured out. He thought this is his classification scheme of galaxies, how we label them. We still use his labeling method today. But he thought that galaxies started as ellipticals and over time turned into spirals as they went on, right? So he thought galaxies started these elliptical, not much shape to them, and as they evolved over their lifetime, they turned into spiral galaxies. We now know that that's not the case. We are pretty sure that and pretty confident that all galaxies will start as a spiral and then move their way to an elliptical. So it's flipped instead of left to right, right to left. And this is because spiral galaxies have a spin to them. Right. So they spin, ellipticals don't. And it's a lot easier for something to stop spinning than for something to suddenly start. Right. So based on how physics and dynamics work inside of these galaxies, eventually what would happen is spirals would stop spinning and then they would form into some sort of elliptical shape. At least that's the idea. That's the hypothesis of what that would happen. The classification schemes, we don't really need to get into. It's just a measure of how round or flat they are for ellipticals, and for spirals, just like how tightly packed the arms are. And so if the idea is how do we see galaxies, like how can we see their evolution and how can they change over time, we have to look back in time to do that, which is why we get the telescope. So our galaxies are kind of, somewhere in this general area, our Milky Way and its structure. But we think about right around just after 400 million years is currently when we expect those first galaxies. It's like debated. This telescope has caused a lot of controversy about this. It's kind of like where somewhat in this area, is where we expect those first galaxies to start to form. Maybe like later out here, I'm not quite their scale, but we're about here. And so to do that, we need to look back in time. And we've done this actually with the Hubble Space Telescope to some degree. So these are not necessarily Hubble, but at least visible light telescopes, so light that see the same with our eyes. These are distant. And so in astronomy, when we say something is distant, we also mean that it's not only far away, but it's also young. So it's appearing young. As we see it, it's young, but it's old because the light has traveled. Like the light itself is old, but the object we're seeing is young. It's annoying, but that's how it's explained.
It's a young galaxy, but it's old light.
Yes. Yeah. Because light has had to travel all this way. I know. Yeah, light's moving and people that upsets a lot of people. So they're very clumpy, right? They don't really have the structure that a spiral does. They're not necessarily perfectly spherical like elliptical galaxies, and we can see, different lobes going on. We measure this in terms of redshift, which will tell us like how much the light has had to travel. And so these are redshifts like 0.24, 1, so just like pretty much in our own backyard, really. And so the big question in astronomy is how we get from these clumpy galaxies to our galaxies, but also how did we get to these types of clumpy galaxies? We want to go right back to the beginning, and that's where we get JWST. Simply because JWST is able to see further back in time. So this shows us kind of in the scale of the galaxy, if the Big Bang is here and we're like up here at the modern universe, how far back in time each telescope can see. So Hubble and different deep fields are able to see till just about here, right on the edge of the approximation of the first galaxies would have started. JWST is able to go pretty much close to where we think the first stars would have formed. And of course, stars are kind of the building blocks of galaxies, right? Galaxies contain stars and gas and dust and all these things. So JWST is able to see much further back, which means we get a much better idea of what is going on to get from these clumpy galaxies all the way to the grand spirals. And that's why this image was so exciting when it was first released. And I'll never not be upset at how they released it. It was like on the smallest screen ever. And I was like, because they did it at the White House. And I was like, I don't think he cares that much. Make it bigger. So that was annoying. But this galaxy cluster, the large white ones are galaxies that are closer to us in the foreground. Is where the cluster is. And the ones near the cluster, like behind and near it, are being warped from gravitational lensing. So if you think of like a trampoline and you put something heavy in a trampoline, it creates that dip. That's what the galaxies are doing to their spot in space, creating a dip. And the light, as it enters that dip, gets like stretched out and warped and magnified and stuff. And this image is like, there's so many things to look at, but astronomers were quick to, go and hunt and peck for the ones that were exciting. And of course, those are their very old galaxies. So this is the SMACS or SMACS 0723 cluster, galaxy cluster deep field, or Webb's first deep field image. And they were able to find about 4 galaxies were highlighted because they took spectra of them. I think they found like 10 different galaxies that are very, very far away. And the light from the furthest galaxy was set at 13.1 billion years. So the light had been traveling for 13.1 billion years before it got to us. And this is why I set the first half with so many pretty pictures, because this is what we're looking at. It's a red speck. So not exciting, but very exciting in terms of like the science that can be learned from this tiny little red dot.
Well, if everyone was at Dr. Riley Hill's talk last week, this was kind of like what he was highlighting, was that when this photo came out, everyone kind of like went towards those pretty spirals, but he kind of was like, no, I'm actually interested in these really weird red ones here.
These really tiny red ones, yeah, that are like kind of on the outskirts of everything else.
Yeah.
Yeah, no, they're very like they're all scientifically interesting, but in context of like earliest galaxies and how they change over time, they are very interesting, these ones. So there was 4 that were highlighted because they got spectral data of them. And then, Webb has kind of continued to look at different galaxy clusters and using this technique with gravitational lensing, which like magnifies galaxies behind it that we wouldn't otherwise be able to see, right? So these very large galaxies, because they warp space-time, because the light gets warped, it like acts as a magnifying glass. And so we're able to see behind the cluster itself. And by using infrared, we're able to see much older or galaxies whose light has been traveling for a longer time. I don't want to get people confused. They're younger galaxies, but the light is older. So this is another deep field image that Webb did of the MACS 0647 cluster, which is the 4, like these clumpy ones here. And a specific system showed up 3 different times. So it was lensed, and then there were 3 copies of it splashed around. JD1, JD2, and JD3 is what they're able to see. Based on the easiest way to measure distance, they think that it's the redshift is at 11. So those earlier galaxies that I showed you from like visible light telescopes, their redshift was like 0.2 or whatever. This is now like 11 or over 13 billion years old, the light is. So it's been traveling for a much, much longer time. They think it's either a galaxy with 2 areas of active star formation, so stars forming in each lobe, or it might be 2 separate galaxies entirely, right? We can't quite resolve it. It would take a bit more study to figure it out. And Webb, this is just kind of what Webb does, right? So it just like looks at the sky for a very long time, collects a bunch of light, and then astronomers kind of hunt and peck for everything. So we found in Abell 2744 with the GLASS survey, we have redshift of 10, redshift of 12, which puts it at a place about 350 million years after the Big Bang. So quite young. After the universe would have been quite young when these formed. And this is kind of where the contention of where we think we should see these very young galaxies starts, because now we're starting to see them at the right time, but they're just a bit more developed than we thought they would have been based on how our science worked before. So again, there's two things happening. One, our measurement might be a bit off for their distance. They might be a bit closer to us, which means they might be a bit the galaxies might not be as young as we think, or we got to relook at how we think stars form and how galaxies form in the beginning of their lives, which is very cool. And this was just another, I think this is the most recent one that that the telescope has put out, or like the teams have put out, of the Pandora cluster, Abell 2744 again. So kind of the same region. It's a huge cluster, and it's actually like 4 different clusters in one area. It's a lot happening. But we have all these different galaxies, the earliest ones as of now, yet to be confirmed by another method of determining their distance. Their redshift is about 7.9, which puts it 650 million years after the Big Bang. So this is the most, like, their science is the most accurate, as opposed to the one that was like 400 million years after the Big Bang. This one's a bit more accurate measurements. And actually what's interesting is that YD4, galaxy YD4, when we first imaged it just using regular old imaging data, we thought it was much further away. But then when we looked at this again with Webb, we were able to narrow down and more accurately place it in time. And so its redshift changed. It was thought to be much further away, and now it sits at about redshift 7.9, or 650 million years after the Big Bang happened. And so we have all these, they're called like galaxy candidates until they're confirmed, but all of these different, I know, because it's just like, well, we don't know. Could be something else. Even like the supermassive black hole at our galaxy was like, when they won the Nobel Prize, it was like a supermassive compact object, because it wasn't confirmed it was a black hole until the image came down in May of 2022. But yeah, so Webb's, ability to look so far back is what will help us, go from these tiny specks of red to these more clumpy formations, and then hopefully help us understand how we get to these grand, large spirals. And what's cool is that just because we see these galaxies as these red specks, they have continued to move on. They don't look like that anymore, right? So they've evolved over time. And so maybe one of those galaxies is that galaxy, far, far away, that we can only think about at the end of it. But that's galaxies. My favorite thing to talk about, actually. Love them. As you can tell. Yeah, love galaxies.
Well, and one of the most amazing things last week at Dr. Riley Hill's talk was that a question was asked to him what he was most surprised about. And one thing that he mentioned was that they didn't expect these young galaxies to have as many stars as they found, right?
Mm-hmm. They're like, so it's described as like being more massive. So they have more mass, which means like there's more stuff in them. Yeah. And Dr. Riley Hill is looking specifically at stellar formation. So just like more stars are there, which we didn't expect there to be based on how we understood galaxies to form. But really, it's like science is quite messy. And so there is a lot of, thinking one thing and then going back and reevaluating and stuff. It doesn't mean it's wrong. It just means the scientific process is happening in real time, is all that's happening.
Yeah. And then, of course, it just gets you speculating, of course, like in the context of the Star Wars universe, that if there are this many galaxies with this many stars, with potentially this many planets, like, are there any of those that could potentially have life? And of course, we're only looking in the small little corner of our little own galaxy. So it's mostly speculation, but that's kind of what Star Wars helps us do, right? It kind of helps us like, this is as much as we know. Now let's just like play in a bit of a fantasy land and a dream of one of those galaxies being our Star Wars galaxy.
One of them could be, it just doesn't look like it to us right now. Who's to say what's happening with any of those galaxies in the current time? We can't see that light. It took, 13 billion years for its baby picture to get to us. So
Yeah.
we have a lot of waiting to do before seeing what's happening to them right now.
Amazing. So this is just another step in almost like our whole year of this JWST series that we're going to be doing. We're going to be doing even more of this in the fall as even more JWST info comes to us. So this is going to be a big year for you, Marley, because this is a topic, like you said, that you're pretty excited about, as well as today, because Star Wars Day is upon us. If you're out there and you're still looking for tickets, online sales have ended, but you should be able to maybe grab one at the door if you're here early. Doors are at 6:30 p.m. Like I said, about 20 members of the 501 Legion are going to take over our Cosmic Courtyard. We've got 3 members of the Andor team that are going to be talking about the making of Andor downstairs in our auditorium. So that is going to be very exciting. Before we end off today, Marley, quick, top 5 Star Wars franchise that you love.
Okay, this is very difficult. I really like Andor. Also, they're coming here. So Andor, actually really good. Closely tied to that, Rogue One, also very good. The Clone Wars animated series, I really like that show, especially the last season and anything to do with Maul. He's very, very funny. I also, this is weird, but I also like the Thrawn novels.
Okay, nice.
Those are good as well. I also read the Padme Amidala novels. Those are also very good. I like those novelizations. I can't list just 5 because there's so many. I like Revenge of the Sith and Kenobi. That show was also very good.
Very cool. You know, I actually saw the last episode of Kenobi in the theater. And it was cool. They live streamed. I don't know if I told you this. Hayden Christensen was not in the theater that I was at, but he was in a theater in Toronto, and they did like a Q&A with him and the director. Was really
Where
cool.
was my invite to this?
I know. I didn't want to make you jealous. So if you're out there watching, throw your top 5 out there.
What are yours?
Let me think off the top of it. Well, I'm gonna have to give you my best experiences, because now if I'm thinking about it, that experience watching the final episode of Kenobi was up there. But if I go back, so number 1, I have to put Jedi as my number 1 because that was my first that I saw in the theater. It was Derek Ewan's birthday party, and
shout out Derek.
And he had got the Luke with the dark black Jedi Luke action figure. So I distinctly remember that. You know, number 2, I'm going to say episode 1, because that's when I was like almost an adult, and we were there lining up in Strawberry Hill in Surrey, which is where I grew up. Well, I grew up in Delta, but we were lined up for that screening, episode 1. We were so excited, and it was just, the energy was amazing. And I didn't even know what I had seen afterwards. Like, I was still like just riled up. So those would be my top 2. And then of course, like Rogue One is amazing. Really like Andor. And I think I'm going to fit in like that last episode of Obi-Wan in there, because that was really fun to see as well.
That was a really good episode. That was a whole good show. I really liked it. Yeah. My friends and I, shout out to Ethan Gomez, who doesn't watch, but we would play Jedi when I was a kid, because Clone Wars was on while I was a kid, and we all had plastic lightsabers, and we would like joust on our bikes with the lightsabers as if we were like on a speeder. Like, it was probably very dangerous, but it was a lot of fun.
Yeah. Sorry, I totally forgot. Probably like up in there, maybe my number 3 then. So if Jedi's number 1 and episode 1 is number 2, Clone Wars definitely number 3.
Love that
I totally forgot about Clone Wars, like one of the most underrated Star Wars things out there. It's so good.
The final season is just
and that's what Pride says as well. Pride is watching, she said, Clone Wars, Andor, Rogue One, Mandalorian, and then probably Ahsoka when it comes out.
Oh yeah, Ahsoka's coming out too. I'm excited for that. I also, yeah, the Mandalorian, I liked the first 2 seasons a bit more than this one.
Yeah.
And I really liked the Book of Boba Fett. That is really good. I'm like, where's the 2nd season, please and thank you. Give me more Fennec Shand, please. So,
and you know what was really great about the Mandalorian is that it came out kind of like during the pandemic. Well, like the 2nd season came out. Like the first season like finished like during the pandemic, and when we were talking with the folks at ILM for our first online May the 4th be with you, like we talked a lot about some of the new technology that they put into that show. We had a great conversation, and I remember like just feeling good having that connection to something that was very familiar to me in that time of 2020 when it was very lonely, and living alone and being connected to something from your childhood. And Mandalorian was kind of like almost a surprise hit. I don't think people really knew what to make of it when it first came out.
Yeah.
And then it was great, and it still is great. So shout out to everyone at ILM. Can't wait to hear the talk tonight. Thank you all for watching another episode of Ask an Astronomer. I will not be back in 2 weeks, but we have a special guest that will be talking about Goodnight Oppie. So for everyone out there watching, your homework is to go watch Goodnight Oppie. It is an amazing documentary on Amazon Prime about the Opportunity rover that is on Mars. It's a fantastic documentary. Marley is going to be joined by one of the makers of Goodnight Oppie. So come right on back here in YouTube land in 2 weeks, May the 18th, 4 p.m. Pacific time. Talk to you all then. May the
Bye,
4th be with you.
everyone. May the 4th be with you.